We are going to see Python data structures in this session. Data structure is a more organized method of data storage to provide the ease of access to the user when it comes to problem solving. Python has primary data types like numeric, which is divided into integer, float, complex, and boolean, and it also has data structures to store collection of values. So strings, list, tuples, they are classified as sequence, and then you have got sets and dictionary. Apart from these data structures, you also have byte arrays and range objects, Unicode strings. But in this session, we are going to see only the sequence data types, sets and dictionary. Sequences allows you to store multiple values in an organized and efficient fashion. Under the sequence type, we are going to see strings, list and tuples. Sets and dictionaries, they are the containers for non-sequential data. Strings, it's a sequence of characters enclosed by a single quote, double quote or a triple quote. Here you can see that this is a valid Python string enclosed by a single quote. This is by double quote. This is by triple quote. But when you enclose it with a triple quote, you can have double quote in the middle. Similarly, when you have a double quote, you can have an apostrophe here. These are all some of the operations that are allowed in a string. Suppose I have two variables A and B. Hello Python. I want to concatenate those two. I can use this operator plus. Repetition will be repeating the values 2 times. Suppose if I execute A star 3, it will be repeated 3 times. Then I can have a slice operator. We have A of 1, that means the array index starts with, the string index starts with 0, 1, 2, 3, etc. So A of 1 will be the E element. And then Python allows a negative indexing also. So the positive index starts from the left side, negative index starts from the right side. So this will be -1, this will be -2 and so on. So B of -1 will be n. I can give a range. So this is the starting element and this will be the ending element. As in range, that last fourth element will not be included. So it will start from 0, 1. So E, L, L will be displayed here. Suppose that starting index is not given, that means it will be taken as a 0. So starting from 0 up to 4, not including 4. I can also have a membership, whether I can check the particular character is in this string or whether it is not in the string. So the values returned will be true or false depending upon the membership or not the membership. These are all some of the string functions. Capitalize converts the first character to uppercase. This is count, the number of times a specified value occurs in a string. These are all some of the string functions. Join is to join the elements of an iterable to the end of the string. Suppose you have a string, I can split that and store it as a list. Tuple. Tuple is containing different values separated by a comma and enclosed by a parenthesis or bracket. This parenthesis is optional. Here you can see that A equal to 1, 2, 3. That means A will be a tuple with the 3 elements 1, 2, 3. Here A comma B is equal to 4, 5. It may look like a tuple, but it is actually a multiple assignment where A will be assigned the value 4 and B will be assigned the value 5. It is an immutable sequence of Python. What do you mean by immutable? We'll be seeing all those mutable and immutable, but by now I'll just tell you the individual element of the tuple cannot be modified. The tuple on the whole can be changed, but the individual element cannot be changed. So these are all some of the operations. As we have seen, you have concatenation, slice, membership, index, repetition, updation in tuple also. So here you can see that A is a tuple with the three elements and B has got three elements, 4 and then string, and then you have a float value. I can just concatenate. So the first element, the first tuple will be concatenated with the second tuple. Similarly, you can have a repetition, slice, and then range. Here also you have a negative indexing. All this membership and then not a membership can be verified. Lists are similar to arrays. It can hold, but the difference is it can hold a homogeneous data. Any type of data can be stored. It can be iterated, like giving the index and finding out the successive elements. And it is mutable. That means the individual elements can be changed. Here you can see that this is a list with the three elements. Here a list sublist is included in this list. Here this is a, so the difference between a tuple and a list are tuple is enclosed by a parenthesis and the list are enclosed by the square bracket. So this is an example of a list, and these are all some of the functions. Here you can see that I have got an append and extend. So since I can add, remove elements in the list, we have functions for appending and extending. So concatenation, repetition, slice, range, slice, membership, they are all same as in the previous cases. But here you can see that li dot append of a. That means with that li, I am appending a. Here you can see that I am trying to append a list. So the whole list will be appended. But when I have an extent, so the list will be taken and each element will be iterated and it will be stored in this list, appended to that list. So that is the difference between append and extend. So append will take the whole argument as one such argument and will append. But here it will iterate over the argument and then it will extend. I have a concatenation here and then I can insert. I'm giving the position here. So in the second position I want to insert an I, and then I just want to find out what is the 11th element, sorry, where the 11 is. It is in the second position. Similarly, I can also have count of 3, how many times 3 occurs. So it occurs in 2 times. I can remove that. So here you can see that I'm just removing the first occurrence. I can also have a reverse. So it will be printed from the right to left. I can also have a sort. So again, these are all some of the operations that can be applied on list. I'm explaining that append and extend further with some examples. So I have a stack with the element 2 elements and then I'm appending. So now I have the stack has got 3 elements. If I'm appending a list, then it will have the whole list will be appended. But here in extend, the whole list will be iterated and then it will be extended. So which is better, tuples or list? Tuples has got some advantage. They are faster than list. They protect the data because it is immutable and it can be used as keys on dictionaries. And you can have multiple value assignment. So x, y, z, a, b, c. A will be assigned to x, b will be assigned to y, and c will be assigned to z. Sometimes lists are also useful. It may be slower, but it is powerful than the tuple. List can be modified and lots of handy operations can be performed. And as we have said, tuples are immutable and have very few features. I can just convert a tuple to a list, similarly list to a tuple by using these two functions. So I can convert a tuple to list using that list function, convert the list to tuple using the tuple function. However, the assignment in built-in data types occur. For integer, float and strings, I have a x variable assigned to 5. But in Python, this 5 will be treated as an integer object and a reference from X is placed on 5. So an integer object is created and then you have a reference object and then there will be a reference made from X to that integer object. I'm just incrementing X is equal to X plus 1. What will happen? Another object will be created with the value 6 and then X will be made to point to that particular object. So we have seen that assignment of built-in data types behaves very normally. I have X is equal to 5 and then I am assigning Y is equal to X. What happens? Both X and Y point to that object 5. Now I am changing Y is equal to 6. When I change that, a new object is created and Y will be made to point to that object. And then I am printing. So far so good. So in the built-in data types, assignment behaves as we expect. But assignment in other data types are different. So you have a list with 3 elements, okay, and then I am assigning A to B. What happens? So A and B will point to the same object. Now I am making change to the original list. I am appending 4. Here 4 will be added, but still that A and B point to the same object. So B will also be having 1, 2, 3, 4. So A has got 1, 2, 3, 4 because we have appended, and B has also got 1, 2, 3, 4 because B is pointing to the same object as A. Now let us see some examples on mutable and immutable. I have a list T with these elements and I am changing this Tom to 4.3. It is permitted because it is mutable. Now we'll see some examples on immutable data types. T is a string. Hello Python. I'm trying to change the first element of the T, that is E by G. When I do this, I get an error because string object does not support item assignment. Now we'll see with the tuple. This is a tuple. I'm trying to change its Tom by 4.3. Now also I get an error because tuple object does not support item assignment. Hope you understand what is mutable and immutable. In mutable data types, you can change the individual elements in the same variable. But here you cannot make changes to the individual element of that variable. More on mutability. When you do assignment versus slice. Now I have seen that the list is a mutable data type. So I have a name which has got 2 elements, hello and world. And I am assigning names to another variable n. Now I am trying to change the first element of that n by Python. So what will happen? We know that n and names point to the same object. So whatever changes I make to n or to names, it will reflect on both the variables. So here hello world, since I am changing this world to Python, I get an hello Python. What will happen when I do a slicing? Here the same names, but here instead of doing the assignment, I am using a slicing operator. When I specify this start and without the start and end index, it means from 0 to the last element. So what will happen? Here it makes a copy to that n. So now if I make changes to n of 1, that will not affect the original list. So in effect, assignment makes both the variables refer to the same object, but slicing will always return a copy. So when you have a copy, you can make any changes that will not reflect the original list. Now coming to dictionaries. Dictionaries are key value pair. Key can be any Python immutable type. That means I cannot have a list here. And values can be any arbitrary Python object. So the key and values can be of different types in a single dictionary. And dictionaries are unordered. You can store the dictionary in one order, but when you are retrieving, it may be you may be getting in a different order. and dictionaries are enclosed by curly braces, and values can be assigned and accessed using square braces. These are all some of the operations I can perform on a dictionary. Now here you can see that I am creating an empty dictionary by giving an open and close curly braces. And then I'm giving an assignment like this. That means I'm adding the first element for the dictionary. The key value is 1 and that value is first element number string. This is the second element. In that second element, this is the key and this is the value. And I'm trying to print the first one. So I get print element number string. So key must be unique. But when you have a duplicate keys, what happens is the last assignment wins. Here you can see that I have an dictionary. This is the key and this is the value. Key, value, key, value, key, value. But here you can see that I have A5 and here also I have A3. But when I print this tiny of A, this 5 will not be printed, but instead that will be printed because the last assignment wins. Here is another example. I have got name Joe, code 67, department sales. If I want to print all the keys, then I can give tiny dictionary dot keys. It will print all the keys. Suppose I want to print all values, I can give dot values. Other operations on dictionary. Here this is one dictionary, one is a key, bow is the value. Okay, suppose I just give D, then you can see that all the elements of the dictionary are printed. Now I say D of 3, comma 4 is equal to A, comma N. What happens now? You get this 4, 3. You are just adding one element. 3 comma 4 is the key and this is the value. That means along with this existing one I am adding this 3 comma 4 colon an. So this is adding a key value pair. Now I am deleting this d of I. That means in the dictionary ith element, that is the element with the key value I and the corresponding values are deleted. We have just seen d dot values display all the values, d dot keys display the all keys, and I can just give d dot items where all the items will be displayed like this. Comparing list and dictionaries, we have just seen list can also have a homogeneous data type, dictionaries can also have a homogeneous data type. But what is the difference? Dictionaries are like list except that keys are used instead of numbers to look up values. So in a list we'll be using the indexes 5, 10, 15, but dictionaries will be using the keys for indexing. Here, this is how I create a list. I'm just appending some items and then I'm just accessing that element. So in a list, key will be 0, 1, 2, 3, etc. and value will be the corresponding values we are adding. The order in which we are adding will reflect the key value. Now this is how I create a dictionary. I am adding the first element, key is age and value is 21. The second element is course 182. Here you can see that course and age are keys and the 182 and 21 are the value. So this is the difference between the list and dictionaries. Now we'll come to the last data structure, set. Set is a collection that is unordered and unindexed. So you cannot index it, you cannot take the fifth element or seventh element. And the order in which you store will be different from the order in which it gets printed. Sets are written with the curly brackets and it also can contain only unique values. So this is how I create a set, and then this is an example. Now you can see that again another example set of another list. These are all permitted. Now these are all the some of the operations I can perform on set. I have two sets, set 1 and set 2. I can have a union, add, difference, intersection, and remove. I can add an element, I can remove element. I can also have a pop, discard. They all do the same operations, but some slight differences are there. You have union where two sets will be joined together, and that duplicate values will be removed, and difference will be the element that exists in set 1 which do not exist in set 2. Intersection will be the common element between set 1 and set 2. So based on the knowledge we have gained, I expect you to write programs for these things. In coming videos, we'll be seeing more on Python loops, decision making statements, functions, classes and objects. Thank you. Happy learning.